So what happens when you don't plug in your computer while doing the video? It turns out that you finish the lesson and realize that you didn't record all of it. So I'm sorry, this lesson comes in two parts. Let's pick up where the last video left off. The last video left off with the square root of 6 minus x. And so I want to give you this one, y equals the square root of 3 minus 2x. Find the domain for this, please. Might want to pause the video while you think about it. Come back if you have questions or when you want to check your answer. Okay, so I know the stuff under the radical, 3 minus 2x, also known as the radicand, has to be greater than or equal to 0. 2x plus 2x, 3 greater than or equal to 2x, divide by 2. X is less than or equal to 3/2. Okay, and so we know that there's 3/2 can be equal to, but x can also be less than 3/2. That's all these numbers over here. So we're going from negative infinity to 3/2. And does 3/2 get a bracket or a parenthesis? Bracket, because 3/2 is included because of this equal sign. Okay, if I plug a 3/2 in here, 2 times 3/2 is 3. 3 minus 3 is 0. Square root of 0 is 0. Yes, I can do the square root of 0. That's why we can do equal to. That's why this point is included. And that's why that's a bracket. Okay, hey, some of you have asked, why is it, Mr. Cooper, that you keep moving the x's over? Why don't you, like I learned in Algebra 1, subtract 3 from both sides? Well, I'll tell you, the reason is because when I get here, and then I have to divide by a negative 2, students say this. But wait, x isn't bigger than 3/2. X is supposed to be less than 3/2. See, what happens is when the students move the 3 over and then divide by the negative 2, they forget that thing they learned in middle school, which is when you have an inequality and you divide or multiply by a negative on both sides, you need to flip the direction of the inequality symbol. Oh, so let's see. Kukla moves this over, and then he just divides by 2. You've got to move this over, divide by negative 2, and you have to remember to change the direction on the inequality. No thanks, I'm going to move the x stuff over, thank you very much. Okay, I don't want to have a negative in front of that x. All right, so I hope that was successful for you. I want to look at some more pre-cal level problems though now. Much of what we've been looking at was Algebra 2 level, so let's take a look at something like this. Okay, we've got x squared minus 2x minus 8. And I know what's under the radical, the radicand, is supposed to be greater than or equal to 0. Well, suddenly my transformations don't work at all. I can't think about this as transformations. But you know what I can do is I can factor this, and I can say x minus 4 equals 0 and x plus 2 equals 0. So x equals 4 and x equals negative 2. And I can call these numbers critical numbers. We're going to use critical numbers a bunch this semester, so no, they're not going away. You might want to take some serious notes right now. I'm going to take those critical numbers and I'm going to put them on a number line. And I'm going to test these values for these intervals. See, I've got 3 intervals. I can even test the values themselves in the original problem. Not in this problem with the equal sign, but here, or even here I could, okay? So if I plug in 4, 4 squared is 16, 2 times 4 is 8, so 16 minus 8 is 8, minus 8 is 0. Is 0 greater than or equal to 0? Yeah, that works. What if I choose a number bigger than 4, like 5? Okay, so 5 squared is 25, 2 times 5 is 10, so 25 minus 10 is 15, minus 8 is 7, the square root of 7. Well, it's not a whole number, but it is a real number. So that works, and this is a yes also. What about a number in here, in between -2 and 4, like 0? If I plug in a 0 here and a 0 here, I'm going to have 0 minus 8, or I'm going to have the square root of -8. That is an imaginary number, so this is not part of my domain. And if I try something to the left of -2, like -3, -3 times -3 is positive 9. -3 times -2 is positive 6. 9 plus 6 is 15. 15 minus 8, why, that's positive 7. Yeah, square root of 7 is a real number, so that's a yes. So, oh, and if I test -2, -2 works as well. So I actually see these numbers work. Don't forget the bracket on -2. And because 4 works, it gets a bracket, and then I go forever. And it can be these numbers, or it can be these numbers. So let's use a little union symbol. That's my domain for this. Okay? Now, there's another way to sort of graphically think about this, by the way, which some of you might be interested in. I still want to find these critical numbers and put them on the number line, but then let's think about this graphically. This is a pointing up parabola, and I want to know when that parabola is greater than or equal to 0. Well, at these points, the parabola is equal to 0, and it's a pointing up parabola. When is the pointing up parabola greater than 0? For all these values, and for all these values. So I don't have to test the intervals sometimes. Ultimately, I'm showing you the testing the intervals thing because, yes, in fact, you will be testing the intervals a lot with some of our problems. And no, you won't be able to do it graphically. But something like this, you can think about graphically to determine the domain. And I think thinking graphically is terribly, terribly helpful, especially if you're moving on to calculus. Okay, so what is it that we did with this problem? We took what was under the radical. We took the radicand. We said, okay, radicand, u be equal to 0. Then we factored. Then we set each factor equal to 0. We called those critical numbers, and we put them on a number line, and then we tested the intervals. And then we were able to write our domain. That's what I need you to do with this problem. Square root of x squared minus 2x minus 3. Please try this one and come back when you're done, or if you have questions. Okay, so if I take this stuff and say it has to be greater than or equal to 0, I can factor this trinomial like this, and then I can set each of the factors equal to 0 and get these two critical numbers. I'm going to put those critical numbers on a number line. Now, when you got to this point, did you use the graphical approach? Did you say when is the parabola greater than or equal to 0 and draw in the parabola and say for these numbers and these numbers? That's a way to come up with negative infinity to negative 1 union 3 to infinity. But since most of the time we won't be able to do that, and we will have to test the intervals, let's test the intervals. I'm going to use 0 and 4 and negative 2. And I'm going to plug these test values into here or into here. Okay, so if I plug in a 0, 0 minus 3 is negative 3. Is negative 3 greater than or equal to 0? No. How about 4? 16 minus 8 is 8, minus 3 is 5. Is 5 greater than or equal to 0? Yes. And if I plug in a negative 2, negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4. 4 plus 4 is 8, minus 3 is 5. 5 is greater than or equal to 0. And so I write my domain like this. Hey, be careful. This test value is not what goes here. The critical number is what goes there. If you put -2 here, I mark it wrong. Because what about all those numbers from -2 to -1 that do work? You need to include those. So we're testing values, but it's our critical numbers that are determining the domain, okay? All right, so we know that most function, so many functions, y equals x, y equals x to the third, y equals x squared, y equals x to the fourth minus 3x to the third plus 2x squared minus 7. All of these have an unrestricted domain, -infinity to infinity. It's very few functions, like y equals square root of x, where we have to restrict the domain. And we know the restriction on this is the radicand has to be greater than or equal to 0. Okay, so we set what's under the radical greater than or equal to 0. Hey, remember, cube root, that's -infinity to infinity. This idea of setting the radicand greater than or equal to 0 depends on the index. Even indices, when this is an even number, like 2 or 4 or 100, that's when I have a restricted domain. Anytime I have an odd number index, no worries, your domain is all real numbers. Okay, so right now we only have one function with a domain restriction, and that's this. Okay, but there is one other of our reference graphs that has a domain restriction, and that one is this. What is it that we can't have in the denominator? We can't have 0 in the denominator. We said a little while ago in an earlier video that while 0 over 1 was 0, 1 over 0 is undefined. That's not part of our function, is not defined when we plug in a 0 in there. So we can't have a 0 in the denominator. No 0 in the denominator. So what am I going to do here? I'm going to say whatever on the bottom can't be equal to 0. In this case, it's 0. That's what x can't be equal to. It can be anything else. It can be all these negative numbers. It can be all these positive numbers. And so my domain is going to come in two parts. -infinity to 0, no bracket because this time 0 is not included. And these numbers over here in positive land that go from 0 to infinity. Notice these are not ones. 0 doesn't work, but 0.1 does and -0.3 does. So if you start with -1 and +1, you're missing out on all these values. Remember, it's that critical number that generates these, okay? All right, so we can't have a 0 in the denominator. What's that going to look like? Okay, here's a function. We've got 1 over x plus 4. Well, I'm going to say x plus 4 can't be equal to 0. And when I subtract 4 from both sides, x can't be -4. On the number line, that looks like this. X can be these values, x can be these values, x can't be -4. So my domain then is going to be from -infinity to -4, union -4 to infinity. Okay, -4 is not included. That's why we have these parentheses here. Okay, and please don't write -4 to -infinity. I have to mark that wrong. Interval notation always has the smallest value to the biggest value, the smallest value to the biggest value, from here to here, and then here to here. We read right to left in our society. Okay, so I think you can try one now. How about y equals 1 over 2x minus 3? Please find the domain for this function. Okay, what do you think? 2x minus 3 can't be 0. 2x can't be 3. X can't be 3 halves. So x can't be 3 halves, but it can be these numbers, and it can be these numbers. So my domain will be negative infinity up to 3 halves, parenthesis, union, parenthesis, 3 halves to infinity. Okay? Now, what about the harder problems? Okay, let's take a look at some harder stuff. How about 1 over x squared minus x minus 6? What's my domain here? Well, I know x squared minus x minus 6 can't be 0. And so let's factor this. It's going to factor as x minus 3, x plus 2, not equal to 0. Hey, if you're a little tentative about your trinomial factoring, we will be practicing that soon. We'll be doing a whole lot on FOILing and factoring. But for now, I'm trying to give you gentle polynomials to factor when you have to factor them. So here, I'm going to say x minus 3 not equal to 0, and x plus 2 not equal to 0. And so I get x can't be 3, and x can't be negative 2. On my number line, can't be negative 2, can't be positive 3. Now, I want to caution you because I get a lot of students who say that the domain here is negative infinity to negative 2, union 3 to infinity. And that's not correct. Because yes, not this, but these work. And yes, not this, but these work. But what about these numbers? These numbers also work. There's no problem with these numbers. If I plug a 0 in here, I get 1 over negative 6. That's negative 1/6. There's nothing wrong with negative 1/6. So, two critical numbers, 3 intervals. Don't miss out on that middle interval. What I notice is most students who don't use this number line approach don't see the middle one. They just take the critical numbers and they write their intervals. They forget about that middle section, and then they get the problem wrong, and we're both sad. So use your number line with critical. Test those intervals. Don't lose that middle interval, okay? All right, let's do a couple more. How about y equals 1 over square root of x plus 6? Well, that's interesting because I know from the radical that x plus 6 has to be greater than or equal to 0. But I know from the denominator that the square root of x plus 6 can't equal 0. So even though this is saying could be equal to 0, yeah, can't be equal to 0 on the bottom. So let's go about finding when this is. We'll subtract 6, and we'll get x has to be greater than negative 6. So I'm going to say negative 6 is a critical number, and I'm going to test the intervals. I'm going to test these intervals, but I'm also going to test negative 6. Okay? Let's start with that. Negative 6. Negative 6 plus 6 is 0. Square root of 0 is 0. 1 over 0. No, that's undefined. But if I put in a number over here, like 2, no, I want to do 3. If I test x equals 3 here, 3 plus 6 is 9. The square root of 9 is 3. I get 1 over 3. 1 over 3 is a real number. That's a yes. And if I plug in something over here, like negative 10, negative 10 plus 6 is negative 4. Square root of negative 4, no, that's imaginary. So look what happens here. I end up with a domain that starts with negative 6 but doesn't include negative 6 and goes up forever. Both the restriction for the radical, that I couldn't have any negatives, and the denominator restriction, the denominator can't be equal to 0, played a role in developing this domain. Sometimes I have to consider both of these restrictions, and always domain is the most restrictive case. Even though denominator says I could have these or these, Square root says, no, you can't have this. And even though radical says you can have this or these, denominator says, no, I can't be equal to 0. So we're always going to take the most restrictive case. So if I have something like this, square root of x minus 4 over x plus 6. I know this guy says, well, x minus 4 has to be greater than or equal to 0, or x has to be greater than or equal to 4. And this says x minus 6 or x plus 6 can't be equal to 0. X can't be negative 6. Well, are they fighting about that? This one says, hey, I got to be greater than 4. And this one says, you can't be negative 6. I didn't want to be negative 6. I just wanted to be greater than or equal to 4. So, okay, I'm not going to be negative 6, but I'm not going to be any of these anyway. So my domain here is positive 4 to infinity. Okay, but if I change this problem slightly, and make this be plus 4 here and minus 6 here. So now I get x has to be greater than or equal to negative 4, and x minus 6 can't be 0. So x can't be 6, and x has to be greater than or equal to negative 4. So here's negative 4, here's 6. I can't be 6, I can be negative 4, or I can be values that are bigger than negative 4. Hey, wait a minute, 6 is bigger than 4. Yeah, but I can't be 6. So I'm going to have to skip 6 and keep going. Now, if you're not sure about that or comfortable with that, just take the critical numbers and then test these intervals. And if you're not sure, test the values themselves. Test those critical numbers too. So let's try that. If I plug in a 0, 0 plus 4 is 4, square root of 4 is 2. 0 minus 6 is negative 6, so I get 2 over negative 6. Yeah, there's nothing wrong with that. That works. What if I try a number bigger than 6, like 12? 12 plus 4 is 16. Square root of 16 is 4. 12 minus 6 is 6. So I end up with 4 over 6. Yeah, that's a real number. But if I plug in 6, 6 minus 6, that's 0. I can't have 0 in the denominator. So that's a big old no. If I come over here and plug in a negative 4, negative 4 plus 4 is 0. Square root of 0 is 0. Minus 4 minus 6 is minus 10. 0 over negative 10, yeah, no problem. That's 0. That's a yes. And if I plug in something over here, like negative 5, negative 5 plus 4 is negative 1. Square root of negative 1 does not work. That's an imaginary number. So what does my domain look like here? It goes from negative 4 to 6. Negative 4 is included because it was a yes. 6 is not included because I got a no. Union 6 to infinity. Okay? Why don't you try this one? And we'll call this one the last one for this lesson. Y equals x minus 5 over x squared minus 9. Figure out the domain for this one. Come back when you have questions or you're done and want to check your answer. Okay, well, let's think about the top. The top is this linear function, x minus 5. And I can plug in any number I want there. When I think about this, the graph of this, I can plug in all these x values and get y values. I can plug in all these x values and get y values. I can plug in any number I want. So the numerator doesn't cause any domain restriction for us. But the denominator, I know I can't have 0 down there. And what is it you're supposed to remember when you take the square root of both sides of an equation? That's right, you're supposed to remember oh God, please don't forget this. Please, please don't forget. When you take the square root of both sides, you must remember the plus and minus. So many people lose so many points because they leave out the plus and minus when they took the square root of both sides of the equation. So I got my number line, and I've got negative 3, positive 3. And if I test these intervals, If I plug in a 4, 16 minus 9, that's not 0, that's a yes. And if I plug in a 0, 0 minus 9 is negative 9. It's no problem having negative 9 in the denominator, that's a yes. And if I plug in negative 4, I get negative 4 times negative 4 is 16 minus 9. Hey, that's a positive number. I can have a positive number in the denominator. The only numbers that don't work are these two numbers. So my domain here is going to be negative infinity to negative 3, parenthesis, union, negative 3 to positive 3, union, 3 to infinity. You might want to write down in your notes the most common mistakes here are people put brackets on these, people leave out the middle section, or people put 9s in these places because they forget to take the square root. Okay? So I hope this was a helpful first conversation about domain and interval notation. Don't worry, we'll be talking about interval notation all semester long, all year long, next year in calculus as well. And domain comes up again a couple of times this semester. So domain is with us, interval notation is with us. Please own this knowledge. Please take notes on these videos and really do active reading with your notes, okay? Don't just watch the video. Granted, watching the video is better than not watching the video, but watching the video and taking notes on the video is what you really need to do. There is a homework assignment tonight for number 8. It's here on page 22 and 50, and I'll have this scanned and in our Office 365 team waiting for you, okay? All right. Have a great day, everyone.